Okay, chapter on electromagnetic spectrum. This is a follow-up after waves. Okay, we have discussed a lot on waves. There are transverse waves, there are longitudinal waves. In particular, in this chapter, all the waves in this spectrum, if you define it, it's just it's a range. It's a range of waves. Okay, electromagnetic spectrum contains many waves. And in particular, we're going to study 7 of these waves, and all of them are transverse waves. And then you can see that this is why we actually go into this chapter. The next chapter on sound only deals with longitudinal waves. Okay, let's move on. So as usual, these are the learning outcomes that you must know. This chapter, actually there is nothing very difficult. It is one of the easiest chapters, but a lot of memory work. Okay, a lot of things to memorize. Okay, you will see how, you see why in a while. Okay, next. Okay, EM spectrum. Okay, as you can see, it contains gamma ray, X-ray, okay, ultraviolet radiation. This whole spectrum here refers to visible light. Okay, there are many different types of light: violet light, blue light, and so on. In particular, O-level likes to test on red light and blue light in terms of, okay, the number here that you see, right, is actually the wavelength. 400 nanometers, 700 nanometers. Okay, the one with the larger wavelength is a blue versus a shorter wavelength, which is larger wavelength is red, shorter wavelength is blue. Okay, confused about the number. And you know that you need to know which one has a larger wavelength and so on. We will come to this in a while. Okay, so total there are 1, 2, 3, 4, 5, 6, 7. Okay, 7 waves in the EM spectrum that we are going to learn about. And in particular, you need to know the wavelength of gamma ray, X-ray, and so on. Okay, I think there's a better slide in a while, so let's move on. Yes, I think this is the better slide. Okay, gamma ray wavelength, X-ray wavelength, and so on. Now, you need to memorize this. In the EM spectrum, the radio waves, microwave, infrared, and so on can be arranged in this particular order. Okay? In terms of, for example, if you look at the left-hand side, gamma ray to radio wave in this direction, you have the shortest wavelength to the longest wavelength. Okay, on the right-hand side, it is also arranged in this order. Lowest frequency to highest frequency. Okay, but how to memorize this? That's the problem. Okay, there is a very fast way for you to remember this, and it's a mnemonic called Ronald McDonald is very understanding, especially to girls. Okay, R stands for radio wave, M stands for microwave, I, very, U, especially to girls. Okay, but still, how to remember whether radio wave has the lowest frequency or no highest frequency? How do we know that? Okay, okay, let's focus on the frequency part. The wavelength will come naturally after this. Okay, radio wave, gamma ray. Ronald, girls. Okay, G for girls, R for Ronald. Which is a guy? Ronald, right? The girl is gamma ray. Okay, so let us listen to their screaming sounds. Ronald McDonald scream. Okay, that's myself. Okay, let's listen to the girl. Okay, someone just died. Okay, listening to these two, right, can you tell whose voice has a higher frequency? Okay, obviously the girl, right? So we can use this logic, okay, to say that gamma ray has the highest frequency, whereas radio wave, on the other hand, has the lowest frequency. Okay? Okay, let's go back one slide. So, we will settle the lowest frequency and highest frequency in this manner. After determining the order, where Ronald McDonald is very understanding, especially girls, we can use the sounds to tell us that radio wave has the highest frequency and gamma ray has, radio wave has the lowest frequency and gamma ray has the highest frequency. What about the wavelength? Direct opposite. If you have the lowest frequency, you must have the highest wavelength. If you have the highest frequency, you must have the shortest wavelength. Let's move on. Okay, as mentioned, blue light versus red light. You need to know which one has a longer wavelength. Okay, answer is this. Highest frequency, blue light. Okay, red light will have the shorter, the lower frequency. Now, important features. These are expected of you when I ask you to describe electromagnetic waves. Okay, EM waves. Okay, you can read that. How would the questions be like? Okay, what type of questions require you to use these answers? Questions like this. Okay, listen up. State the difference between EM waves and sound waves. Okay, what do we know? Okay, actually you don't know yet, but EM waves can travel through vacuum, whereas sound cannot. We will learn that in the next chapter. Okay, we also know that EM waves are transverse waves, while sound waves are longitudinal waves. Things like that. Okay, or the question can be like this. State 3 common characteristics between gamma ray and X-ray. Okay, you know that they are all in the EM section, right? So the 3 characteristics can come from here. This one, and this one. Okay, actually the point number 3 and point number 5 are repetitions of each other. I would actually prefer that you lump them together like this. This is actually redundant. Okay, it's subsumed under here. EM waves can travel through vacuum at the speed of light, 3 times 10 to the power of 8 meters per second. Okay, this one, EM waves transfer energy from one place to another. This is not very precise because longitudinal waves also transfer energy. So it's not a very good answer that I would like. Okay, let's move on. Okay, for your own background knowledge, this is not tested. Okay, I'm going to skip. Okay, how do we know that EM waves transfer energy from one place to another? The infrared radiation, which comes to us as heat from the sun, it can be felt, right? It can be felt. So we know that the EM waves have traveled some distance to reach us. Okay, we know that EM waves exhibit wave-like properties such as reflection and refraction. Okay, EM wave can travel through vacuum, as mentioned earlier on in the example of infrared waves from the sun coming to us. There's a region of space between us and the sun. Okay, this region of space, right, we normally call it outer space, but actually, do you know that it's vacuum? There are no air particles. But at the same time, EM waves can travel, and that is one characteristic of EM waves. Okay, EM waves are transverse wave, and so we know already it travels with the speed of light, 3 times 10 to the power 8 in vacuum. Now, this is one particular question that could be asked, asking you to state the region P and Q, fill in the blanks. It's arranged in some order from radio wave to gamma ray. So what's the answer? Radio wave, Ronald McDonald is very understanding, especially to girls. So X-ray and infrared. Alright, using that mnemonic. What is the speed of X-ray in vacuum? Okay, rubbish. 3 times 10 to the power 8 meters per second. Redundant question. Okay, but it's an important question. It is sometimes you need to assume that this value. When it's not mentioned in the question, you must know. Okay, that the speed of X-ray, which is part of the EM spectrum, the speed of X-ray in vacuum is a constant value of 3 times 10 to the power of 8 meters per second. What is the wavelength here? Okay, let me show the working. Pause first. V equals to F lambda. You want to find wavelength. Lambda equals to V over F. The speed of radio wave. Okay, we know this. 3 times 10 to the power of 8 divided by the frequency. 9 times 10 to the power of 7. Okay, answer will be... Okay, I need to calculate this. Round it off to 3 significant figures. 3.33 meters meters. Okay, 3.33 meters for the wavelength. Let's move on. Okay, now this is the part you have to memorize. In particular, you need to memorize the uses of the different waves in the EM spectrum. For example, radio wave, what is the uses? Especially this. Okay, telecommunications. Okay, the reason why I highlight this is like a standard answer. Okay, it is used in telecommunications. For microwaves, okay, satellite television and telephones. You can also say it's used in microwave ovens to heat food. For infrared radiation, okay, usually the more common answers are remote control and intruder alarm. For visible light, okay, information transfer via optical fibers, like this. Or, if the question asks you for the medical procedure involving visible light, it is in endoscope. Ultraviolet ray, it is used for sun tanning, it is used for security paying to check the authenticity of bank notes. Okay, so actually I would do this. This portion is a bit too lengthy. What I would do is, okay, to detect fake notes. Fake notes. Okay, this is the usage of ultraviolet rays. X-ray, okay, X-ray photograph to detect. Okay, you must tell me what to use or what to detect fractures. Okay, that is the main purpose it is being used in the medical field, to detect fractures. Okay, just for information, everything above, right, other than the wavelength, you do not have to know. Gamma ray. The usage is gamma knife radiosurgery. Please note the full name. Do not just give me radiosurgery, or do not just give me gamma knife. It is gamma knife radiosurgery. Okay, you can say sterilize. Okay, students like to write this as sterilization. Full stop. Sterilize what? Okay, must be precise. Sterilize medical equipment. Okay, then it serves a purpose. Okay, but precisely to actually reduce infection when you perform medical procedures. Okay, sample questions. Which has the shortest wavelength? Okay, this answer is gamma ray. Okay, using the mnemonic gamma ray. Okay, this one you have to memorize. Sorry, no choice. Okay, highest frequency, X-ray, right? Okay, lastly, this one. Okay, I think this is the best possible slide, I believe. Okay, on the wavelength of gamma, on the wavelength of X-ray, violet, ultraviolet ray, and so on. The previous slide in the earlier part of this set of notes, so I think the values are not very nice. Okay, let's use these values instead. Okay, they are in meters, 10 to the power of 2 meters, 10 to the power of -2 meters, and so on, for the wavelength of the different types of waves. Okay, lastly, okay, this is just background knowledge for you. I will let you read by yourself. This will not be tested. Okay, so it's optional. You can have a read. Okay, okay, this one have a read as well. And if you're more interested, there is a detailed explanation, discussion on EM spectrum on YouTube. It's quite a lengthy video. You can have a look whenever you're free. And lastly, this is just a roundup of whatever we have gone through. Okay, 14 minutes and 18 seconds. Done.